In this video, we will be checking how to solve the problem for finding the best time to buy and sell stocks with some constraints attached to it. The constraints being that on each day you can buy one stock and sell one stock. You have to first buy before you sell them, and the constraint being that at most you can hold one stock at a time. So you can repeatedly keep buying and selling the stocks, provided that you can only hold one stock at a time, and the input provided is going to be the prices on relevant days. So on day 1 the price of the stock is 1, on day 2 price of the stock is 2, something like that, and we have to return what is the maximal possible profit that can be made using these constraints, that you buy first just one stock and then you sell just one stock. You can buy and sell on the same day if you want, but there is no constraint that you can only buy once and sell once. You can buy and sell multiple times. Only constraint is that you can hold at most one stock at a time, and that is the problem statement. This is a variant of another problem that we solved earlier, which is that you can buy stocks on a specific day and you can only sell them at a later date in the future, and you can only buy once and sell once. So this is a variant that is a bit more trickier version of it, wherein now you can buy and sell on multiple days, following that you sell only after you buy, that being the logical approach, and that you can only hold at most one stock at a time. That's what we are going to be dealing with, and we will be building a solution in JavaScript and also compute the space complexity and time complexity of the solution that we will be building here. Now, with respect to the solution aspect of it, we can take a greedy approach, and we can say that I will try to find the maximum profit that I can accumulate by just buying and selling the stocks on the next day, provided that on the next day the price is higher, and I will keep trying to accumulate whatever profits I can make, and then in the end whatever maximum profit I have, I will just say that's going to be my max profit outcome from my algorithm. I will try to be a bit greedy with this one and just see if on the next day the price is higher, I will just sell, and then I will again check on the next day. If the price is higher, I will again sell, and then I will accumulate the profits that I made. And having said that, let's jump into trying to explain how this mechanism of taking a greedy approach will work. Basically, we will do a forward single pass through the input array that we have received, and we will go from the start towards the end, and in a single iteration we will try to find what's the maximum profit that can be made by just accumulating the probability of making a profit whenever the sell price will be greater than the buy price. Basically, the next day having higher price compared to your current day, and that will look something like this. So we have this constraints that we have to follow, that you can buy one stock and sell one stock, and you can at most hold one stock at a time. What I will do is I will start with this one, because this being our initial, I want to make sure that when you sell you have something that can already be possibly bought. So if I start from here, there was nothing that could be bought before this, because this is the first point you can buy from. So I will start from the next pointer, which is here. I will check if the prices on this day and compare them with the prices on this day. So I will say 2 and 1. I will compare these two. Is 2 greater than 1? If 2 is greater than 1, that means I can make profit, and I will just say my max profit is going to be 2 minus 1. So I sell them at 2 and I bought the stock at 1, which gives me profit of 1, and I will keep a track of this. Then I will shift my pointer by one iteration. I will go to 3. I will say, is 3 greater than 2? Yes, 3 is greater than 2. So I will say do 3 minus 2. That's the profit you can make. And I had profit here, which was already 1. I will just keep accumulating the profits now. That's the greedy part of it. I will see whatever the possible profit can be made and keep accumulating it over my input. So I will say 3 minus 2 is 1, and 1 plus 1 is going to give me 2. So now my latest max profit is 2. Now I will again move forward and I will go to my next iteration. I will check, is 4 greater than 3, the previous one basically, and I will say yes, it is greater. 4 minus 3 is 1. I had 2. I will do 2 plus 1. Now I'm going to get 2 plus 1 is 3. Similarly, I will go to the next iteration. I am here now. I will say, is 5 greater than 4? So yes, 5 is greater than 4. That means I can make profit. I will just do 5 minus 4, which is 1. I will do 3 plus 1 now. Keep on accumulating the profit that can be made. And now I am ended up with a profit of 4, and I have reached the end of my input. And this is going to be the maximum possible profit that can be made. I just kept on accumulating the profit by selling on the current day, provided it was brought on the previous day. So I have just buy it, and then the next day I see if the price is greater, I just sell it. And that's the whole logic aspect of it. And in terms of the approach, this is called as a single pass, because I go only once through the entire array. I don't keep any trackers of my previous value. I just go from the start towards the end in one go, and I just keep comparing my current and my previous, and if profit can be made, I just keep accumulating it. And that's pretty much it in terms of the logic, considering this constraints that we have. And let us now go and convert this into code aspect and see how it will look in terms of code. So what we said is we will keep a accumulator that will keep track of our maximum profit that we have. So I will just say max profit is 0 to begin with, and then in the end I'm just going to return my maximum profit that can be possibly made. Then I said I will go in a single pass. So I will start with one index. I will go until the length of my prices that I have, and I will just use a loop. And the reason we started 1, because you need to have something that is bought before you can sell. If you start at 0, there was nothing bought, because that's the starting point. And then what I will do is I will just see if the prices on my current day are greater than the prices of my previous day. So I will just say if prices on my current day are greater than the prices on my previous day, which is I minus 1, then I will just say that max profit accumulation is going to be my current max profit that I have plus prices of I, which is my current day prices, minus prices of I minus 1. And that's pretty much it in terms of implementation. We just accumulate the best profit that can be made using a greedy approach, and at the end this accumulated value we are just going to return. In terms of implementation, that's pretty much it. And in terms of time complexity, the time complexity of this approach is going to be big O of n, because as we said, we do a single pass, start from the beginning of the array towards the end of the array. That's why it's big O of n. And in terms of space complexity, it's going to be big O of 1. Reason being that we're just using a tracker here and just keep on updating the value in that tracker. So we don't use any additional storage that is required. It is just going from 0 till whatever possibly maximum value you can accumulate, and then just return it. That's why the space complexity is going to be big of 1. And now we have covered this use case with the constraints that we mentioned. That is, you can just buy one stock on each day and sell one stock. You cannot buy multiple and sell multiple. Now let us tweak this a bit and go on further and try out something that will be saying that instead of just selling one stock, which we were doing right now, we could only sell one stock. Now let us say that we can sell any number of stocks. So you can buy one stock, but you can sell any number of stocks, provided that you have those stocks. And then we get rid of the constraint that we put initially, which said that you can hold at most one stock at a time, because now you can hold more stocks. And now let's tackle this variant of the problem. So initially the approach was that on each day you can just buy one stock and you can sell one stock at max, or you can choose not to sell any stocks or buy any stocks. It's up to you. And now what we will see is a variant wherein you can buy one stock and you can sell any number of stocks that you have. And in this also, the approach is going to be that we want to find the maximum profit that can be made. So we went from the start towards the end in this scenario. Now we could go from start to end because we were considering a local view, as we were just following in a greedy sequence and just trying to find the max profit that can be made by selling on the next day and buying on the previous day, considering that you could make profit. Now we need to expand our view a bit and see a global view aspect of this problem statement, because now it says that you can sell any number of steps. So you don't have to buy, sell, and then again buy. You can just buy them in a sequence, and then at a later date where you can make a lot of profit, you can just sell them all at once. So we need to now find the maximum price that we can sell them at, and then based on this determine what is the possible profit that can be made. So the difference is, before we're just checking the immediate consecutive days, wherein the next day if you could say that profit can be made, we will just taking the difference from the current day and the next day and trying to find the profit. Now we will see what is the maximum possible price you can sell, and then try to compare difference from that price. And that will go something like this. You will start now from this index, that is the end, and you will go all the way to the start. The reason being that we now have to find the highest possible price you can sell at before we can determine the profit. So what we will say is, keep track of 2 pointers. So one is the maximum profit that can be made, and another is the maximum sell price that you can have. So these 2 pointers we will keep track of. Before we were just keeping a track of 1 pointer, now we will keep off of 2 pointers. So we will start with this one, and we will say that initialize the max sell price to 0, and what we will say is compare with your current index the maximum sell price. If it is higher, then it just gets updated whatever the max price is there. So in this case we became 5. Then we will say that the maximum profit that can be made is going to be whatever max profit you currently have plus the difference between your max selling price, which is 5, and your current price that you have, which is this one. So you will just say 5 minus 5, which is going to give you 0. So at the start your max profit that you can make is 0. Then we will go one iteration lower, and from this index now the pointer will shift down to the previous index that we have, which is going to be 4. So now we will say move the index backward. We will still go in a single pass, but instead of going from start to end, now we change our focus from end to start. And we will say that what is our current index that you have with us, which is going to be 4. We will compare this 4 with the maximum selling price that you found so far. You have 5 here, so 5 is greater than 4, so this doesn't change in any way. You will see whatever max profit you had. To that, what we will say is just accumulate the difference from your max price and your current price, which is going to be 1. So now max profit will change from 0 to 1. That can be possibly made. And similarly, we will just move forward in the iteration now. So from here, we came here. Now we will again compare this one with your max sell price tracker that you have. Still 3 is less than 5, so this doesn't change in any way. We will say whatever your max sell price is there minus your current, which is going to be 2. So we will just accumulate. So before we had 1, now to 1 we will add 2. So now it becomes 1 plus 2, which is going to be 3. So now it's going to be 3. That is going to be our current value. Then we will move our pointer again. We will bring the pointer to 2 now, and we will check 2 and your maximum track of your sell price. Still 5 is greater, so max sell price remains constant. Then we will say 5 minus 2, which is going to be 3. Now this value you will accumulate with your current max profit, so it's going to be 3 plus 3, which is going to give you 6. Similarly, we will move the pointer again, and now the pointer will be at 1. Now what we will do is compare 1 with 5. 5 is still greater, so that can be your max sell price, it doesn't change. So then I will do 5 minus 1, which is going to give me 4. Then I will accumulate this 4 with my 6 that I had, and in the end I will be left with 10. And then I have reached the starting index. I cannot move any further in backward direction, and I stop here. And the max profit that can be made now is 10 in comparison to the previous approach wherein the max profit could only be 4, because in this you could sell at any time in the future, but you can only buy one. So we can repeatedly buy, and then at the highest point in time wherein the prices are very high, then you can just sell. So this is going to be called as the reverse single pass approach. This is also a greedy approach wherein you try to see what is the max selling price that you can have, and then just keep on going on accumulating the prices that you can get. And in terms of code aspect, this implementation will look something like this. So before we were going in a forward pass from starting towards the end. Now we will say, instead of going like that, just go from end to start. So I will say go from the length that you have -1, and you have to be in positive index, and just keep decrementing the index that you have. And in terms of the tracker, we said we are going to keep track of this max sell price that you can have. So I will say max sell price is going to be 0 initially, which I start with, and then this max sell price will be compared with your current iteration, which is going to be prices of I that you have, and whatever the higher value is going to be there, that's going to be your max sell price all time. And then what we will do is whatever max profit you had, you will just keep accumulating it with your max sell price minus prices of your current iteration that you have, which is going to look something like this: plus equals the max sell price that you can have minus your current index that you can have. And that's pretty much it in terms of reverse pass approach that we have. In terms of the time complexity, it's also going to be big of n, because now instead of going from start to end, we are going from end to start. So the time complexity also remains big of n. In terms of space complexity, instead of using one tracker, we are using two trackers, but this still is constant storage. We're just using two trackers and updating those values as we move forward in the iteration. So that's why the space complexity is also going to be big of 1 itself. And that's pretty much it. So what we did was we started with a variant of a simpler problem statement of buying and selling stocks, wherein in the original version we could just buy one stock at a time and sell it at another point in time later in the future, and we could only do one transaction. So you can buy and later in the future you can sell, and that's pretty much it. Then we covered the variant wherein you can buy and sell one stocks, but you can do this multiple times, not just once. And then at the end we covered another variant wherein you could buy one stock any number of times, and then we covered that you can buy one stock on each day, and at a later day you can sell any number of stocks that you currently have. So we removed the constraint that you could only hold one stock at a time. So these are the two variants of the original problem statement that we covered in this video. I hope you liked it. Please like and subscribe. Thank you for watching.